The sample proportion, again, is the proportion of individuals in a sample that have a specified characteristic. So if we were talking about people who had brown hair, we could take a survey of people in this class versus a survey of people in Miss Caldera's class or Miss St. Clair's class, and we have a different sample proportion for those different sample sizes. Let's suppose that a random sample of size n is obtained from a population in which each individual either does or does not have a certain characteristics, brown hair. The sample proportion denoted p hat. So look at this little symbol right here. It literally looks like a P with a little hat on it. It's called p hat, which is one of the funniest things to me. It's called p hat. P hat, which is the sample proportion, is given by this formula, p hat equal to x over n, where x is the number of individuals in the sample with that specified characteristics. Kind of think like successes in chapter 6. The sample proportion p hat is a statistic that estimates the population proportion. We're not going to think too hard about this. It is literally a proportion. So our class size is, well, today it's 11. LOL, come to class. So our n would be 11. If we were doing this, number of people with brown hair, which is everybody but Liam, so 10 out of 11 would have brown hair. Even if your hair's dark, so potentially black, I'm counting it as brown. Okay, that is a proportion, a sample proportion. 10 out of the 11 people in here have brown or black hair. That's it. We're not overthinking this formula. The number we see out of the total number. So example 1, a Harris poll conducted a survey of 1,200 adult Americans who vacation during the summer and asked whether the individuals plan to work while on summer vacation. Of those surveyed, 522 indicated that they plan to work while on vacation. Find the sample proportion of individuals surveyed who plan to work while on summer vacation. So we are finding p hat. And p hat is simply equal to the number of people who we observe doing this trait, which is how many people? Out of the total population that we are surveying. What's our total population? 1,200. That's our sample size. I guess I shouldn't say population, our sample size. So 552 over 1,200 is 0.46, which is 46%. It goes back and forth on whether you want a decimal or a percentage as your answer, so just make sure you read for what it's asking for. But 46% of people while they're on vacation would work. Let's say that we take a second survey of 1,200 adult Americans who would likely have a different estimate of the proportion. So like, let's say you take another 1,200 people and 600 of them say that they're going to work while on vacation. Because this value of p hat, again, sample proportion, varies from sample to sample, it makes it a random variable just like our sample mean was last time, which means that we can then find a probability distribution describing the shape, the center, and the spread, just like we did for sample mean. So our formulas we're going to be using for the sampling distribution of p hat, the proportion. For a simple random sample of size n with a population of p, we will know that it is going to be approximately normal, meaning we can use our pink paper, if the following thing happens. If n times p times 1 minus p is greater than or equal to 10, then we can use the normal paper. And the normal paper for us is that pink table, the normal distribution. Now, what is n? Great question. N is your sample size. P is the population proportion, and so 1 minus P would be like the opposite sample proportion. The mean of this data is simply the proportion, and the standard deviation is the square root of P times 1 minus P over N. These are going to be things that we're able to calculate pretty easily with a calculator, which is why I'm not having you pull open Excel today. But this table right here is probably very important for you. It has your formulas. This is where you're going to be looking a whole bunch. Now, to be able to use these formulas, the following 2 requirements must be there. Your data must have been obtained randomly, which goes back to chapter 1 in the ways that you pull samples. So you're just looking for in the blurb that it was obtained in a simple random sample or a random sample of some kind. If you can prove that, then you're good. You can keep using these formulas. The second thing is the sampled values must be independent of each other. That is, one outcome cannot affect the success or failure of any other outcome. But when sampling from finite populations, which means like not infinite populations, we verify independence requirements by just simply checking that the sample size is no more than 5% of the population size. So you're going to use this formula right here that the sample size you're working with, n, is less than or equal to 0.05 times the population size. So if we were doing something from Mesquite High School students, our population size would be the total student count. And if I only surveyed this class, that would be 11 people. We'd make sure that 11 is less than or equal to 5% of the entire student body, and it would be considered to be independent. Those are the requirements there. But then we can use the stuff from the main ideas table. Would you like to see an example of us using the stuff from the main ideas table? No, we're doing it no matter what you say. So example 2. Suppose the proportion of Americans who believe that the state of moral values in the United States is getting worse is 0.76, so 76%. Suppose we obtain a simple random sample of n equal to 60 Americans and determine which believe that the state of moral values in the United States is getting worse. We're going to describe the sampling distribution of the sample proportion, which means we are talking about the center, the spread, and the shape. That's what this little blurb right here, when it says describe the sample distribution, that means we're doing shape, center, and spread. Okay. Now, before we start using my formulas, we have to check those 2 requirements. The first requirement is that it's done, this sample is gotten randomly. In our blurb right here, does it say the word random? Yeah, we obtained through a simple random sample, so that's good. We have step 1 achieved. Step 2 means that we need independence. And the way that we check independence is we make sure our sample size, n, is no more than 5% of the population. Okay, what population are we studying here? Americans. Do y'all know how many Americans there are?
A lot.
A lot. Estimate is right now about 300 million. Is 60 less than 5% of 600 million?
I would say so.
So in your calculator, do 600 and then 6 zeros following it and multiply that by 0.05
4, 5, 6.
times 0.05. Is 60 less than that number?
What's 1.2 times?
Yeah, so it's definitely less. So our sample size of 60 is small enough compared to our population, because our population is 300 million Americans. So we're good.
You have me do 600 and then 6 zeros. No.
300 and then 6 zeros.
Oh, I don't
But once you know that it's still good?
It's still small.
Yeah, okay. Once you know it's obtained randomly, check. And that they're all independent, check based on sample size. Now we can start to use the formulas. Okay? The formula we're going to check for size is n times p times 1 minus p greater than or equal to 10. This is what we're checking for the shape. N is the sample size. What is my sample size here? 60. P is the probability of the characteristic we're looking for. So we're looking for the people who believe that the state of moral values in the United States is getting worse. What's that probability? 0.76, which means 1 minus P ends up being 1 minus 0.76. In your calculators right now, what is 60 times 0.76 times 1 minus 0.76? I would use the number of parentheses I did.
10.944.
We'd get 10.944. Is that greater than or equal to 10? Yes. If the number we get right there is greater than or equal to 10, the sampling distribution of p hat is going to be approximately normal. That's the first question. That's the shape. Approximately normal. The formula for center, the mean, mu of p hat, is just going to be equal to the statistic that we have, that sample population, which means, boom, I already know it's 0.76. There's the center. The formula I'm using for sigma, for my standard deviation of p hat, is the square root of p, I'll write it down since it's actually a formula, times 1 minus p over n. So if we fill that in, what was p again? 0.76, which means we do 1 minus 0.76, all divided by my sample size, which was 60. So we throw that in a calculator, square root of 0.76 times minus 0.76 all over 60.
0.551.
We'll just go to 2 decimals here, 0.55, sorry, 3 decimals. And so we have our spread. This is sigma of p hat. So anytime it asks you to describe the sampling distribution, you have 3 answers. You're telling me the shape, the center, and the spread. Questions? If you're like, Ms. Quigley, where'd you pull these formulas from? From the main idea box on the front page. But once we know that we can describe the center and the spread and know that it's normal, we then can extend this idea to compute the probabilities of a sample proportion. We're going to go back to using your pink tables for the standard normal distributions. According to the National Center for Health Statistics, 15% of all Americans have hearing trouble. In a random sample of 120 Americans, what is the probability that at most 12% have hearing trouble? Okay. First things first, when it says at most 12%, what inequality am I using here? Well, just at most.
Less than or equal to?
It's actually less than or equal to. Because at most means that's the largest it can be. It can be less than or equal to 12% or 0.12. Okay, cool. So we have this statistic for all Americans. This is the probability of my population, or the proportion of my population. It says in our simple random sample of 120, what is the probability at most have 12% hearing loss or hearing trouble? So if we look for the mu of this p hat, it will be exactly the proportion of the population where this happens, which is 0.15. The other thing we need to be able to figure out this probability is the standard deviation of p hat. So we use that formula, which is 0.15 multiplied by 1 minus 0.15 all over the sample size, which is how many? 120. You know what we should have done before we even started this? We needed to have checked that we're allowed to use these formulas, but let's just do it fast. First rule is that it has to be random. Are we random? And the second one is that the population or sample size has to be less than 5% of the population. So Liam, do you still have that number? What was 5% of the U.S. population?
5% is 600 million.
600, well, the U.S. population
The
is
population
300 million, so it's 5% of that.
5% of that.
multiply by 0.05. Mm-hmm.
It's
15 million?
yeah.
Yeah, is 120 less than 15 million?
Yeah.
Yeah, we're good. We're still using a small enough sample size where we can assume independence. So boom, then we're actually allowed to do these two formulas. Sorry, I should have said that first. And so we calculate this, our standard deviation of p hat, to be 0.0326. We'll keep a couple extra decimals here. Now the reason we wanted the center and the spread, the mu and the sigma for this particular statistic is that we need to figure out the z-score for this particular value. Meaning we're going to find the z-score where the number I care about is 0.12. I subtract the mu and I divide by sigma. If you're like, Ms. Quigley, what formula are you using? Thank you so much for asking. Remember, z-score is always the x that you have or care about, the random variable, minus mu over sigma. And that extends on to when we're doing sample populations, or proportions, sorry. So the one that I care about, the random value for this particular question is 12%. My mu is 0.15. My sigma is what we just got. Z-scores, we always round to 2 decimals. And if we calculate this, this is negative 0.92. So the question that we started off here with is what is the probability that at most 12% have hearing trouble? Which means we're really trying to answer what is the probability that we would have less than or equal to 12% of people with this statistic. We found the mu, we found the sigma so that we can find the z-score and go to your pink table. What is the probability that someone would have less than or equal to 12% hearing loss? 0.17879, which again is 17.879%. Depending on how the question is asking for the answer. Okay, if we're filling in our graph here so you can see it this visually, we know the mu is 0.15 and we were trying to find less than 12%. So we were looking on this side of 12%. So that, again, you can make sure you know we're looking at the left side of this, so we read exactly off the table and we don't need to do 1 minus. I started to put these here so that we get the directions correct for this. We'll stop right here because the lunch bell is about to ring. We just have one more question before you get a whole bunch of homework time. Oh, look, there's lunch. Enjoy lunch. All right, we're back. It says part B here. So we're still working with the example that says 15% of all Americans have trouble hearing. That's the statistic we have, the proportion of the population that we are working with. It says, suppose that a random sample of 120 Americans who regularly listen to music using headphones, probably too loud, results in 26 having hearing trouble. What might you conclude? This question that says, what might you conclude, is really asking, is this unusual? What's the percentage for unusual?
Oh, less than 5%?
Less than 5%. Very good. Okay, so that's our end goal, is figure out if this proportion is unusual. So let's find our p hat.
Okay.
How many people in this population, or in this sample, sorry, have trouble hearing?
120.
What's our sample size?
120.
What is 26 over 120?
0.2167.
Yeah. Okay, so that is the proportion of this sample that has this characteristic. We need to extend this and compare this to the population. So we're trying to see what is the probability that p hat would be larger than or equal to 0.21667. Okay. Now, I put greater than inside a probability. So what does that mean I'm actually going to compute? 1 minus the probability that p hat is less than or equal to, or just less than, sorry, 0.21667. To do this, we need a z-score.
Okay.
To find a z-score, we need the mu and the sigma. We already figured those out in the last question, though. Hooray. So let's find the z-score. The z-score we're going to use here for this random variable will be x, which is 2.167, minus 0.15, divided by 0.0326. This is the mu and the sigma that we got from the question above this. We're going to round to 2 decimals here.
2.0.
Should be 0.6 with rounding. Now that we have this z-score, we can go look at our standard normal. So remember, if we were just labeling this normal distribution here with our information, we're trying to see the probability that our proportion would be here. This is why we decided to subtract, because we want the opposite side of the curve than what is given on our table. So if we go back to, not our z-score necessarily, but back to finishing this, we need to find this probability from the z-score. So on your pink paper, find 2.06. So I'm doing 1 minus that number, 0.898030, which would be 0.0197.
What I found doing the 1 minus is if it's positive, go to the negative side and you find it. It's the same.
Sure. Now, let's just do this percentage because sometimes this is easier to look at. If I change this number to a percentage, what percentage is that? 1.97%. So question, is this unusual?
Yeah, no. Yeah.
What was the percentage for unusual? 5%. So is this pretty unusual since my probability is 1.97%? Yes. Our percentage makes this, this is unusual. That's an unusual population for us to find that have hearing troubles. Yes.
What he said was true, so why don't we subtract doing a -1?
Great question.
Just ignore the negative.
Because technically the standard normal tables tell you the probability to the left side. So by complements, we should be doing 1 minus to get the right side. It's just the correct math to get you there.